In this lecture, we are going to look at the handling of interrupts on the PIC 16F877. The PIC 16F877 has 15 sources of interrupts. Most of these interrupts are generated during the operation of the various peripherals that are on the device. All these interrupts, when enabled, cause branching to address 04H. Therefore, the interrupt saves routine must be located at address 04H. Because all the interrupts cause branching to the same address, there is need for the ISR to first check which interrupt has occurred so as to handle it accordingly. Checking is done through checking the states of the various interrupt flags. Only the register PCL, which is the lowest 8 bits of the program counter, is saved when branching to an interrupt saves routine occurs. Any other register will need to be saved before the board of the interrupt saves routine has been executed. And after the board has been executed, the registers would need to be restored by the SR before exiting it. Registers that need saving are the working register, the status register, the PCLAT register, and the FSR register. These registers can potentially be changed by the interrupt saves routine. And when they are changed, they will cause the operation of the PIC to deviate from what is intended after return from the interrupt service routine. The PIC 16F877 has 5 SFRs that are used to control the various interrupts on it. These SFRs are INTCON, PIE1, PIE2, PIR1, and PIR2. The INTCON SFR, found in all the 4 banks, is a collection of interrupt flags and interrupt enable bits for those interrupts that are core to the PIC 16F877. RBIF is the interrupt flag for port B on change interrupt. INTF is the interrupt flag for external interrupts. Timer 0IF is the interrupt flag for timer 0 on timeout interrupt. RBIE is the interrupt enable bit for port B on change interrupt. INT E is the interrupt enable bit for external interrupts. Timer 0IE is the interrupt enable bit for timer 0 on timeout interrupt. The PEIE bit is an interrupt enable bit that enables or disables all interrupts that are associated with peripherals on the microcontroller. So this means if we make that bit to be a 0, the PIC will not respond to any of the peripheral interrupts. The GIE is the global interrupt enable bit. It is used to disable or enable response to all the interrupts on the microcontroller. So if we reset it to 0, then the PIC is not going to respond to any of the interrupts. PIE1 and PIE2 are SFRs that are a collection of interrupt enable bits for interrupts associated with the various peripherals that are found on the PIC 16F877. We'll discuss more about each interrupt when we get to discuss about the respective peripherals. PIR1 and PIR2 are SFRs that contain the corresponding interrupt flags for the respective interrupts associated with the various peripherals that are found on the PIC 16F877. Mikro C is a predefined function for the purpose of handling interrupts. The programmer only needs to develop the code that would be required to handle the interrupts. This code must be inserted as the body of the predefined interrupt function. Since the function is used to handle interrupts from all the possible sources, an if-else construct may be used to check which interrupt has occurred and then handle it accordingly. This is the typical body of the interrupt function. In this case, the code inside the board first checks if the interrupt was due to timer 0. If that was the case, the corresponding handler would be executed. If not, the ISR proceeds to check if the interrupt was due to port B on change. If that was the case, the corresponding handler will be executed. If not, the ISR may proceed to check all other interrupts so as to get the actual interrupt that would have caused branching to the interrupt service routine. After getting this interrupt, the handler can then handle it accordingly. The interrupt handler function has inbuilt context switching. This means that the critical registers, that is, the working register, the status register, the register FSR, and the register pclath, are automatically saved on entering the interrupt handler and also automatically restored just before leaving the interrupt handler. Therefore, there's no need for the programmer to handle context switching. The programmer only needs to develop the code to handle the various possible interrupts.